Hello everyone, how are you? Am I audible? Hello, am I audible? Hi, let's wait for 5 more minutes and let's get this class table first. People are leaving and joining. So we'll start at 6:10 and we will solve the assignments of this week and it's this year's assignments and last year's assignment of week 1 today. And that these assignments will help you in your final examinations, which is supposed to be in I think October or November. November I think so. So let's wait for 5 more minutes and let's start. So yeah, let me share my screen. We are solving this week's assignment one. Sorry, this year's assignment one, week one assignment. How many of you, I think 4 people are here. How many of you have done it? Can you raise your hand? How many of you have submitted assignment one? Guys, am I audible? Can someone unmute and let me know if I'm audible or not? or type in message. Hello. Okay, anyways, I'm starting. Is the screen should be visible? Uh, Take a note of it. Take a note of it because these questions might be asked in exam, the final exam which you will be giving. Okay, and like, be attentive, and if you have any doubts, just let me know. Okay. So right now the strength is say 8, 6, 1, 2. My screen is not visible. Just a second. Show this one. The strength should be 7 then. No problem. 7 is fine. So social network analysis can be applied on which of the following domains? Okay. So the domains are healthcare, cyberspace, marketing, all of the above. The answer is given all of the above. But anyways, I will give you an explanation why the answer is that. So in healthcare, actually, I worked a project back in my BTech where the problem was the hospitals are not connected about anything, the resources they have, the blood supplies, etc., the pathologies. So we developed a social network of hospitals where the hospital managers will be managing the stuff by like buying and selling and whatever they want to do. They can make a barter trade or that. So that's how the healthcare system can be connected via a social network. Cyberspace, you already know, cyberspace is the thing which we are using, social media and everything, that is already connected via social network. So it can be applied, social network analysis can be applied here. Marketing is also, social network analysis is, can be applied to marketing as well, where we can study how the marketing influences the patterns of distribution and sales, etc., with the consumers. So yeah, so the answer is all of the above. I don't think so you guys have any doubt in this. The next one is in egocentric network, the central node and its neighbors are referred to as. So egocentric itself is giving up. Egocentric means the central node is ego and the other one should be something else. So the central node is ego and its neighbors should be then alters, because if the central node is alter, the neighbors cannot be ego. So yeah, this is the correct answer for this one. Okay, so what is the place complexity of adjacency matrix? So adjacency matrix is basically matrix which tells if any edge exists between two nodes. So we have n nodes in a graph, so we will make a n cross n matrix. So that will be like the space complexity will be O(n) square or OV square, because V is the number of vertices. The time complexity to check if there exists if an edge exists between two nodes using adjacency list. So to check if there is an edge between two nodes, the answer should be the degree of the node, because basically you have to check what should I say, this should be an adjacency list. Okay, adjacency list, yeah. So for assume there's a node A and it has a degree 3, so you will have to basically search linearly in that space to find if there exists the node number, say node K is attached. So node A and node B are attached and node A has degree 3, so adjacency list of A will be of length 3, and there you will have to search node B and the linear search time will be O(n). So that is the degree of the node. Had it been adjacency matrix, the complexity would have been O1 because we know the position of both the nodes and we could directly access them. So yeah, that's that. So remember, this adjacency list and adjacency matrix both have their pros and cons. List consumes less size but increases search space, while matrix consumes more space to be stored but consumes less time while searching. I don't think so any doubts will be here till now. If you have any doubts, I can explain it. Just let me know. Just raise your hand if you have any doubts. Okay, so next, coming to the next question. How many edges are there in an undirected complete graph with 10 nodes? So this is a very nice question. So undirected graph means that you don't have any direction, and complete graph means that every node is connected to every other node. Okay, so it's like that. So there's a simple way to do it. It's like a handshake problem you might have solved in class 11, 12 probability permutation combination. So if there are 10 people in a room, how many handshakes are possible at max? So the answer is basically first person has to shake hands with 9 people. The second person has to shake hand with 8 people because it has already shaken hand with the first person. So that's how it goes on. So the answer is basically 10 into 9 by 2, that is 45. So there will be 45 edges. In a complete bipartite graph, the number of edges is, so there are m nodes on one side and nodes on the other side. So the total number of edges will be m into n. We already know that. It's a simple question comparatively. Okay. Any doubts till now? Guys, any doubts? You can unmute yourself and speak if you want. Okay, no problem. Once I start asking, people start leaving. So anyways, the adjacency matrix of an undirected graph is always, it is symmetric because the edges from A to B and B to A, they are the same edges, so it's always symmetric. That's why this thing comes up to 45 and not 90. Okay. In a hypergraph, an edge can connect more than 2 nodes, any number of vertices. Okay. So which of the following is not link-centric view? Link-centric, unipartite graph is link-centric because the direction, the flow of link determines whether the graph is unipartite or bipartite. Sine graph, the edges have a number on it, and that's why it's link-centric. While ego network is node-centric because their node is the main portion of focus and all other edges are connected to the same node. Okay. So very simple question. Coming to the last question. Which of the following is not standard level network analysis? It should be megascopic because in PPTs, in slides, you might have studied these things: micro, meso, and macroscopic. So any doubts till now? Okay. So this is the week 1 assignment. I have discussed it. If you have any doubts, just let me know. Anyways, I will also discuss last year's assignments as well. So just stay put. Let me log into another ID. I think this should be visible, right? This folder is visible, Google Drive folder. Can anyone just let me know, like raise their hand or something? I don't know if it's visible or not. Okay, thank you. So I think Sumaya, you joined late. We have already discussed week one assignment. If like I will upload the recording today only, and you can visit the recording if you want. But anyways, let me discuss last year's week one assignment. So went to 2024. This should be visible. I hope so. Last year's the question were a bit tough, but anyways, no problem. I will be zooming it. Okay, so social network. I will be discussing. You know what? I will be discussing 2023 and 22 as well. So this way, like you will have a lot of set to practice on for exams, and you can visit this recording anytime to get to know more questions. I cannot upload these because I'm not permitted to in the Google Drive, but the recording is still visible to you. Anyways, let me start. So social network analysis cannot be used in healthcare domain. You already seen it can be used, so false. In egocentric, the central node is called alter, and network its neighbors are called egos. See, the same question asked in a different way, it's false because the central node is called ego because it's egocentric. Obviously, the alters are called neighbors are called alters. What is the time complexity to check if an edge exists between two vertices using adjacency matrix? Had it been an adjacency list, the answer would have been O of degree of the node, but since it's matrix, the answer is O of 1. That's what I was telling you. I hope this is clear to you. How can you represent undirected graph using adjacency matrix? So see, it's just a similar question, just asked in a different way. So undirected graph is always represented using symmetric matrix. A directed graph is represented using asymmetric matrix. How many edges are there in undirected graph with 19 nodes? Undirected complete graph. It should have been complete graph because 19 into 18 is 342 and 342 divided by 2 is 171. Yeah, so this was ambiguous. People could have raised concern, but they didn't, so no problem. I don't know if there is or not. Which of the following best describes an edge in hypergraph? Can connect a number of vertices, including possibly more than 2. Because a let me just open a whiteboard. Sumaya, am I audible? Can you unmute yourself and just like interact with me because I think my network breaks off and that's it. So I will be asked this. I will be raising this. I think you asked it yesterday. Anyways, I will be writing it here. So normal graph is like this. See, there is one node, there is another node, there is another node. Okay. So it can be. Let me add one more node to make it look beautiful. So see, a node can have more than one edge. See, a node can have, this has 2 edges, this has 3 edges, this has 2 edges, this has 1 edge. A node can have more than 1 edge, more than 2. It can have infinite, I would not say n, I would say infinite number of edges. But an edge can have only 2 nodes, see, or 1 node. If I make it a self loop like this, in directed graph, self loop is quite famous because it gives a bidirectional ability to the graph. Okay, but in undirected graphs it's not used generally, but it's used, it's generally not used. So an edge can have at max can be connected to 1 node or at max 2 nodes. Like what if you want to connect more than two nodes, greater than two nodes. How will you do it? Any idea, Sumay? Just answer it. Like if you say no, I will explain it anyways. Okay. So say, let me just show you. I say this, 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 this. These are four nodes. Then this, 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 this. Okay. So this. Let me just make some weird connections. Okay. So this is a normal graph. Okay. Now I want these four nodes to be connected by a single edge. So what I will do is I will draw something like this over this, and this becomes basically a community, a cluster, and it can be referred to as, but it's not, because I will just tell you why. I'll tell you why. And I want these four nodes to be connected by a single edge. Okay. So now this is known as hyperedge. These two things are known as hyperedges. And this whole setup is known as a hypergraph. I mean, these edges also exist there, but this like, although these edges are existing, but still this is known as a hypergraph. Okay, so in hypergraph, an edge can connect any number of vertices, including possibly more than two. Got it? Somewhere? Cool. So again, micro, meso, macro. Always remember, mega is not used in graph analysis. Why? Because this macro and mega represent the same thing only. Micro is node properties such as degree of a node, the edge has direction or not, etc., etc. Meso is community detection. So see, had it been a community, meso analysis would have been applied here, but it's just an edge. Okay, this is just an edge, so that's why this thing comes under micro analysis. I'm poor at writing with mouse, but anyways. But had it been a community, which you will study later on, so problem is that community detection algorithms basically predict if there is a community or not. Okay, so communities are basically predictions. Communities are weak links, means that a member can go out of the community and come in the community anytime based on its other connections. But a hyperedge is static, it does not change. Okay, it should not change, it should not disappear like that based on some other edges, like its own properties, its own interaction with the edge or other nodes should weaken it. It should not be like it's belonging to some, like it start behaving, hyperedge starts weakening because the interaction of the node inside it changes with other nodes, etc. Okay, so the criteria should change. It's like if else, if this node belongs to this new edge, it should come inside it. So if the problem is, if else properties change, then only hyperedge dissolves. But a community is more like a continuous space flow thing. Okay, it can change based on the interactions later in the later stages. Okay, so that's the difference between community and a hypergraph. Okay, so that's why this is micro and this is meso, not meso. Meso. And the overall properties of graph is like it's a directed graph, undirected graph, blah blah blah. They are macro. There is nothing like mega. Okay, so that's that. And what will be the adjacency matrix of this network G1 in figure 1? So 1, 2, 3, 4, 5, 6, 7. So 1, 1 to 1 is there is no edge, 1 to 2 there is an edge, 1 to 3 there is an edge. Okay, so 1 to 2, 1 to 3 there is an edge, 1 to 2, 1 to 3 there is an edge, 1 to 2, 1 to 3 there is an edge. This means this row is correct for 3 of them. Okay, anyways, like you can just go through it and see. I'm just showing you minimized version. I'm not solving it, it's grunt work, won't take a lot of your time. Okay, just let me know if you have any doubts. I don't think so, it's a very easy question. Okay, so anyways, let's move on to the next one. What is the characteristic of many real-world networks in terms of node connectivity? So it's scale-free networks. We have studied tomorrow. If you go to, sorry, we have studied yesterday. If you go to the video which I posted yesterday on my YouTube channel, you will find it. The link to that can be found in the announcements. If you like, let me minimize it. If you go to announcements, and if you go to this recording sheet, and you open this, I've added week 3 because yesterday was week 3 and today is the week 2 session which we missed on the first week of August, I think so, because I was busy as a conference, etc. So yeah, this is that session where we have discussed everything. I'm closing it. Okay, so yeah, the property is scale free. Which of the following is not link centric? Equal network, again repeated same question. Okay, so 2024 is done. Let's go to 2023. Week 1. This one was nice. This line assignment was nice. Okay. So anyways, I will start. If you guys have any doubts, just raise your hand like this. Okay, I'll solve it out. So social network analysis can be used to analyze different relationships present in a society. True. It's a very philosophical question, and yet the answer is true. In egocentric network, again the same thing. The ego central node is called ego. It's not called order, so this will be false. What is the space-time complexity of adjacency for the adjacency list representation? So it will be E plus V. It should not be V square, because you basically see, you write all the nodes and all the edges alongside it. Let me just show you. Let me give you a visual representation, then you will come to know. So let me take this graph only. 1, 2, 3. Let me make this node 4. So adjacency matrix of adjacency list of 1, 2, 3, 4 will be 1 is connected to just node 3. So I will write it like this: node 3. This is a list. 2 is connected to node 4, 3, and 4. So I will write 3, 4. 3 is connected to node 2 and 4 and 1. 1, 2, 4. 4 is connected to 2 and 3. Okay, so this is adjacency list. So you can see here, this is V, and this is like 1 edge, 2 edges, 3 edges, 4, 5 edges. So this is V plus E. So yeah, that's why, where is it? That's why it's known as E plus V, not E square, not V square, not even EV. Got it? So why is it clear? Okay. So E plus V means the space complexity, means the how many space blocks are required to store this matrix. Okay. So had it been adjacency matrix, it would have the size of 4 cross 4. Correct? So this would be V square, because there are 4 into 4, 16 blocks here. Now this, how many blocks are required? See. So the blocks required are just 1, 2, 3, 2. Okay. So this is like Number of edges here are 1, 2, 3, 4, and if you sum this up, you will find it equal to 8. Correct? Which is like double of that. 2 into 4. Correct? But as you can see, like if I write 1 is projected to 3, and if I don't write 3 is projected to 1, I can remove it. That's completely fine because I have already stored this relationship. And 2 is projected to 2 is connected to 3 and 4. So if I remove 3 is connected to this thing, that's also fine. So 3 is connected to 4. 4 is connected to 2 and 3. I don't need to write this. Now how many edges are there? 1, 2, 3, 4. Correct? Now hello, am I audible? Hello, am I audible? So, ma'am? Okay, sorry about that. Actually, there's some network issue. Just a second. Let me just do some boilerplate stuff. Yeah. So I was explaining something. I was saying, assume like, let me just go back. How to undo it? Command Z. Okay. So like, see, this has 8 edges. This has basically 8 numbers inside it, which is double the number of edges. But just follow me, okay? So 1 is connected to 3, 2 is connected to 3 and 4, 3 is connected to 1, 2 and 4. But 1 is already connected to 3, so I do not need to write this. And 2 is connected to 3 and 4, I do not need to write 2 as well. I just need to write 3 is connected to 4, okay? Now 4 is connected to 2 and 3. I don't even need to write this because 2 has already connected to this thing and 4 is connected to 3. I can remove this as well. So now 1 is connected to 3, 2 is connected to 3 and 4, and 3 is connected to 4. So how many numbers are there? 1, 2, 3, 4. Correct? Hello. So now you can see here, like this equals to 4 equals to number of edges. So now you need basically need, I would say, number of vertices for rows and plus number of edges for column spaces. Correct? So that's why it is O of V plus E plus V or V plus E. Are you following it? Cool. Okay, so coming to the next thing, the time complexity for removing an edge from graph is higher when using adjacency matrix or adjacency list. So as I already told you, the searching part is difficult when you're using adjacency list, but storage is small. So see the number of storage, if you want to see, it's 16 here, it's 16 here, and it's just like, I would say, 4 plus 4, 8 here. So although this takes less space, but the search time is greater. Okay, searching is greater in this side than in this side. So list matrix. That's why removing an edge takes longer in adjacency list compared to adjacency matrix. In adjacency matrix, you just need to, removing an edge, you just need to flip a bit. Okay, you just need to write 0 in place of 1, 1 in place of 0. Time complexity is O of 1. Just have to find the edge, delete it. Okay, here you have to find the edge. So you have to find basically where if 2 is connected to 3. So you go to 2, you search if 3 exists. So time complexity is O of degree, first of all. Okay, so that is again this thing. So if this O of D is greater than O of 1, that's why search space increases here. Okay. How many edges are there in undirected complete graph of 6 nodes? So again the same thing. You solve it. 6 5s are 30 divided by 2, 15. Same formula. Got it? How many edges are there in the clique of 5 nodes? A clique is a complete graph basically. So again, clique is basically 5 into 4, that is 20 by 2 is 10. Okay, this should also be easier to interpret. Got it, Sumay? Okay, if anybody has any doubt, just let me know. Okay, I will explain it. Which of the following is not link centric? Ego network is not link centric. I already told you. Megascopic. So you see, like these two questions are obviously repeated every year. Again, how many columns will be there in adjacency matrix representation of network C? So, if you write adjacency matrix or adjacency list, see, if there the answer is if this is adjacency matrix and there are 7 nodes, so the number of rows and number of columns will be 7 into like 7 and 7 same. Had it been adjacency list, the answer would have been different. The number of columns would be the node, the maximum degree of a node. So maximum degree here is 2. This has degree of 5. This has degree of 2. This has degree of 3. So this will be 5. Okay. So number of maximum column possible is 5 here for now for this graph. If this was adjacency list. If this was list, but it's not a list, it's a matrix, so no problem. Yeah, nodes and networks and graphs cannot be used interchangeably because graphs can a network is a graph, but a graph is not a network. Okay, any network is a graph, but any graph is not a network. And graph of protein interaction is not a network; it's just a graph. Okay. Just keep in mind this thing as well. Now let's go to 2022. By the way, any doubts till now? I think this will have some other repeated questions, but no problem. Any doubts till now? So my just a second. Yeah, let's start. A social network analysis cannot be used in cyberspace domain. False. It is cyberspace domain is the first thing where social network analysis is used. In egocentric graph, again, ego is center. Same repeated question, I think. What is the space complexity for adjacency matrix representation? Again, of v square, not of v plus v. This is for adjacency list and not matrix. Which of the following best describes an adjacency matrix for undirected and weighted graph network? The adjacency matrix of undirected and weighted network is symmetric. Had it been directed graph, it would have been asymmetric. Okay. How many edges are there in undirected bipartite graph of 6 nodes, 3 in each row? So 3 3s are 9 because, let me just give you an example. Like it's asking maximum number of possible edges. So this is one part, this is another part. This can connect to 3 nodes, this can connect to 3 nodes, this can connect to 3 nodes. Answer is 3 into 3. That is 9. Got it? 9 is the answer. How many edges are there in clique of 5 nodes? Again, I already solved it. 5 fours are 20, divided by 2. That's 10. Which of the following is not node centric? Ego network, link centric. Ego network is node centric view, by the way. This I already solved. What will be the adjacency list representation of G1? So C. 1 is connected to 2, 3. C. 1 is connected to 2, 3. The answer should be C. Let me explain C only. 2 is connected to 1 and 3. 2 is connected to 1 and 3. 3 is connected to 3 is connected to 1, 2, 4, 5, 7. 3 is connected to 1, 2, 4, 5, 7. Am I like visible? Hello. Uh, just hold on a second. I need to ping. Okay, so see, 3 is connected to 5 nodes. 1, 2, 7, 4, 5. 1, 2, 4, 7, 1, 2, 4, 5, 7. Okay, so that's how you can find it. Again, the answer is megascopic. Megascopic is not a type of network analysis. So this is the discussion of week 1 of previous all the years combined. What I'll do is I'll also just show you week 2. Just also I'll show you week 2 as well. Which is this one? I think I got to the wrong course. Just a second, let me log in by a different ID. I have lots of email IDs to manage this stuff, and sometimes I forget which one to log in. Okay, so coming to week 2. Is it visible? Okay. A deadline is passed now. Yeah. In linearly connected chain, the average degree is 1.6. Using the relation, compute the number of nodes. See, where's my output? So the formula is already given to you. 2e by n is equals to 1.6. But how many edges are there in chain? So edges are always n minus 1. How? If there are 2 nodes in a chain, their edge will be 1. If there are 3 nodes, edge will be 2. If there are 4 nodes, edge will be 3. So you write 2 n minus 1 by n equals to 1.6. That is 2n minus 2 is equals to 1.6 n. So you make it say 0.4 n equals to 2. N is equals to, I think I'm doing something wrong. 2 by 0.4. This should be equal to 5. I'm not sure it's correct or not. You guys, let me just ask ChatGPT. What's the answer? It should not be 8, it should be 5. Yeah, the answer is 5, it's not 8. You guys didn't raise any concern over this. I need to strike this question out from final evaluation. Week 2 question 1. Anyways, just like I'll change the answer to it. Doesn't matter, I will ask them to change the answer. Actually, I can also change. Let me check. Let me check if I can change the answer. Hold on a second. Hold on a second. I need to ask them to change it. I think I cannot change it. Let me check anyways. It should be week 2 group 1. What is the correct answer? Just a second. A, B, C, D. I need to do it like this. My courses. Hold on a second. Go to course, week 2, assignment 2. The answer is 1, 2, 3. No, the answer should be 1. The answer should be 1. Okay, it's a part of mock assignment. I need to ask them to change the answer. Okay. Anyways, let's solve other questions and see if the answers to them is correct or not. In a circular network with an nodes, each node is connected, additional edges connect. Okay. Between alternate nodes. An additional diagonal edge is connected between alternate nodes. What's the average degree? Let me just ask ChatGPT if the answer is correct or not in the first place. let's solve some simple question and see if we have done something wrong or not. Okay, so there are four nodes. Common nodes are B and C. Total number of nodes should be A, B, C, D, E, F. So that is 2 by 6. The answer would be 0.33. This is correct. Yeah, 2.5 is correct. 2.5 is correct. New average degree. Oof. 2.5 is correct. So I'll solve it. Sorry about that. If we add a disjoint set of skip one diagonals, okay. So assume I have a network of circular nodes. Let's make it 4. 1, 2, 3, 4, 5. Five nodes by 4 edges is what? 5, 4 ones are 4, 1.25 something. Yeah. Okay. And additional diagonal edge added between alternate nodes. Okay. So if I add like this edge, and if I miss, I'll define it. Alternate. Okay, so one edge is fine. Okay, so now we compute the degree. How many initial nodes were there? N nodes. Okay, so now there are 6 by 4. I don't know what's the math exactly. Okay, anyways, I'll solve this and I will discuss in next class. Okay, don't worry about it. I will come up with a solution. I think there are some problems with this assignment. I need to check. If graph has 6 nodes, total number of directed edges. The directed graph has 6. Let's solve this one. Okay. Directed graph, total number of edges equals the sum of out degrees. Okay. Also equals the sum of, okay, so with 6 nodes each having out degree 3, there are 18 degrees, 18 total degrees. So the what's number of edges will be 18. Answer is correct. Okay. So anyways, I'll discuss this tomorrow. Sorry, next week, that is 15th of August, I think so. So hopefully Independence Day you have guys are free and to attend the session. Anyways, I'm sorry, this answer is wrong in this assignment, but anyways it will be corrected. It does not need to be removed because the answer is not ambiguous, it's just wrongly marked. What is the diameter of binary tree? I already solved this question. Okay. So anyways, I think that would be all for today. Let's meet tomorrow. Next week. Next week is 15th of August, Friday, and we will solve your doubts and discuss stuff. Okay. Do you guys have any doubts? So okay, I'll solve it now. Let me ask ChatGPT to solve it slowly so I can solve it. So Okay, solving. Just a second. Oh, the formula for degree was wrong. Okay, it has to be 2e. So assume you have a cycle. This is 2e by number of edges. I think we have solved this question. This for chain. Okay, the formula is actually the same. The number average degree. Okay. So in cycle, the number of edges is equal to number of nodes. I did something wrong there. It should be 2. Okay. So for n by 2 nodes, out of n nodes, n by 2 nodes, you add an edge here. Okay. So 1, 2, 3, 4, 5, 6. So I add one edge here. I add 1, 2. Okay, I need to basically make it something. I think only one edge is required or not. Okay. So anyways, just assume like we had how many edges were there out of 6, not 6, 7 by 2, 14 by, it should not be like this, it should be, let me, then add additional diagonal edges added between alternate nodes. Okay, so let me add, so this one if I add here, and if I add one edge here, now if I add one edge here as well, so everything is connected then in that case. So because see, this I add one edge from here to here, then I add one edge from here to here, and then I skip this node at, so there were like 2 times. Initially there were 6 edges, now there are 3 edges, and that is divided by number of nodes 6. So that is 18 by 6. 6 plus 3 is 9. It should not be 18 by 6. Okay, I need to check this question. How is it doing that? I'll solve it next class. Okay, Somay. Sure, then see you. Bye bye guys. Sorry about that. I will fix answer to this and I will come up with a solution to this question. There's something weird about this. I think the language is not clear. If it's the case, then we will have to like try this question out. How many of you had solved this correctly? Okay. So anyways, I'll just check it and see if there's some problem with this or not. If the question is wrong, I'll get it stricken out. But if it's correct, I will find a solution and discuss with you guys in the next session, that is on 15th of August. Okay, till then, bye bye, take care. Have a lovely weekend or Sunday, like Saturday is already weekend. Sure, then see you, bye bye guys.